Okay, let's look more at some compounded interest. If money is invested at 10% interest and it's compounded quarterly, the future value doubles about every 7 years. So use that fact to complete this table. We start with $1,300, and let's say it doubles in 7 years. So doubling the original amount there means that you would have $2,600. In another 7 years, it's going to double again to $5,200. Then in another 7 years, it'll double again, being $10,400. And in another 7 years, it'll double again to $20,800. Create an exponential function rounded to 3 decimal places that models the discrete function in the table. So, to find an exponential model, like we've been doing, we want to put this data in our calculator. So we'll go to the Stat menu. Remind you where that is. The Stat menu is here. And then we want to edit it. So we choose option 1. And we put that data into our list. Now I've already entered it into my list, just to save time in the video. So once I have it entered into the list, I want to find the exponential function. So that's regression. I want to stat, calculate. It says exponential model. So I'll choose exponential regression. And let's see, I don't know if I cleared my y equals screen or not. No, I didn't. I want to clear my y equals screen and then do my exponential regression and tell it to store that regression equation in y1. Now, let's calculate it. Here's what I get when I calculate it. 1,300 for A and 1.104 for B. So that's A equals 1,300 times 1.104 to the x power, set around to 3 decimal places. Now use the rounded function to find the value of the investment in 8 years. So it says use the rounded function. So that means not the exact value, but now I want to instead put in that rounded value. So that's going to be 1,300 times 1.104 raised to the x power. Okay, so use the rounded model to find the value in 8 years or in, oh, I used the wrong year there, 13.5 years. So let's do it for 8 years first. If I put in 8, that's going to give me 2,868.77. If I do 13.5, there I did 3.5. Let's do 13.5 years. That money will be worth $4,943.40. Now, let's do one more interest problem. What lump sum must be invested at compounded monthly at 10% for the investment to grow to $68,000 in 15 years? So let's write down what I know about this problem. I know the interest rate is 10%. I know it's compounded monthly. And I know my time is 15 years. So my N Number of times a year it's compounded is 12 because there are 12 months in a year. 15 years, so my time is 15. My compounded interest formula is P times 1 plus R over N to the NT power. I know the amount, I want it to grow to 68,000, but I don't know what I'm starting with. So I've got to find the P in this problem. So when I set this up and plug in what I know, I'll have 68,000 equals P times 1 plus my interest rate over my N would be 0.10 divided by 12. Raised to the 12 times 15 power because it's 15 years. So now let's figure out what this is. All we've got to do is find P. If you look at this, this is just some number times P. So let's figure out what that number is. I want to put in my calculator the 1 plus 0.10 divided by 12. Oops, 12. And then I want to raise that to the 12 times 15th power. So I get 4 point something. Okay. Well, that 4 point something is just this part here that's being multiplied by my P. And the P is what I'm trying to solve for. So if I'm trying to solve for P, all I need to do here is divide both sides of that equation by this 4.45 number. Now, I don't want to round it off. I want to keep it in as much of the form as I can, as many of the decimal places as I can. So I'm going to use one of those smart things my calculator does and put in 68,000 divided by, now I want it to use the answer from the previous line, so I can arrow up and get that number and press enter, and that gives me $15,267.45. So if I started with 15,000 in 15 years, I would have 12,000. Oh, I'm sorry, I would have 68,000.